The objective of this lesson is to divide a decimal by a whole number using base 10 blocks. In previous lessons, students used base 10 blocks to represent decimal numbers. In this lesson, we will use decimal representations of base 10 blocks to help us divide decimals by a whole number. We will look at examples of partitive division where the whole number represents the number of groups. Let's begin with this situation. After Mom ate 1/10 of the pizza, she wanted her 3 sons to equally divide the other 9/10. How much will each son get? In this situation, we will use 9 base 10 blocks to represent the 9/10 of the pizza the boys will be sharing. Since there are 3 boys, we will divide these blocks into 3 separate groups. Let's begin by giving each boy 1/10, then continue until we've partitioned all 9 of the 1/10 blocks. We can see here that each son will receive 3/10 of the pizza. 3/10 plus 3/10 plus 3/10 are 9/10, as mentioned in the story. Similarly, 3 groups of 3/10 are 9/10. Each son received 3/10 of the pizza. We represent this numerically this way. 9/10 divided by 3 is 3/10. Our next problem states, a local restaurant calculates that every 1 5/10 loaves of bread will feed 5 customers. How much do they calculate that each customer eats? To begin, let's represent 1 5/10 with our base 10 blocks. Here is a whole, and here are 5/10. To divide this into 5 groups, each group representing a customer, we need to ungroup our whole into tenths. A whole is equal to 10/10, so we will bring in 10/10 in exchange for the whole. We now have 15/10. 1 5/10 is equivalent to 15/10. We can now divide our tenths into 5 groups. Let's do it the same way we divided the pizza earlier, by giving each customer 1/10 until we've partitioned all 15/10. After dividing our tenths into 5 groups, we can see each customer eats 3/10 of a loaf of bread. Numerically, we represent the problem as 1 5/10 divided by 5, which equals 3/10. Each customer eats 3/10 of a loaf of bread. The objective for this lesson was to divide decimals by a whole number using base 10 blocks. We met this objective by representing each problem using base 10 blocks, then partitioning the blocks into the number of whole groups stated in the problem.